Let's take a look at Descartes' Rule of Signs. It's kind of an interesting theorem that basically doesn't tell us what the zeros will be, but whether we will have positive or negative ones. So basically what we do is we start by looking at the number of sign changes of a polynomial, and we count the number of sign changes. And if we find, for example, that there is 5 sign changes, then there will be 5 or 3 or 1 positive real zeros. And I get that 5 or 3 or 1 by subtracting even numbers, by subtracting 2's away from that. For the number of negative real zeros, we do the same thing, but we substitute in negative x into our polynomial. Now that's really vague until you see an example. So let's look at this problem really quickly. We're given our polynomial. We really don't care about the numbers. We just look at the signs, negative, positive, etc. This is negative, then we have positive, so there's a sign change there from negative to positive. Another sign change from positive to negative. No sign change between the x to the fifth and x to the fourth terms because they're both negative. We have a sign change from there to there, there to there, and there to there. And so there are 5 sign changes. Now we did this on the original function h of x, and that tells us that there are 5 or 3 or 1 positive real zeros for this function. It's the same as the number of sign changes, or less than that by subtracting 2's, or by subtracting even numbers away. Now, if we want to determine the number of negative real zeros, we find h of negative x, which will be, and I usually don't write it out this long way, but here we go, negative 4 times negative x to the 9th plus 6 times negative x to the 8th minus 5 times negative x to the 5th minus 2 times negative x to the 4th plus 3 times negative x to the 2nd minus a negative x plus 8. Now we're going to simplify all that out, and that gives us 4x to the 9th because we have negative times negative. Now a negative to the even power is positive times 6, so we're going to have plus 6x to the 8th. That becomes a negative times a negative, so we have plus 5x to the 5th. Our x to the 4th term becomes positive times a negative 2. That makes negative 2x to the 4th. We'll have plus 3x squared plus x plus 8. Now we count the number of sign changes we have here and find out that we have positive, positive, positive. There's a sign change. There's a second sign change. There are only 2 sign changes. And that basically means that there are 2 or 0, not positive, but negative real zeros to this polynomial. Now the powerful thing about this is if there are no sign changes, back up here in the original problem, no sign changes means no positive real zeros. And that means if you're trying substitution or trying to try different values in synthetic division, you don't need to try any of the positive real zeros. Or if after substituting the negative in you find no sign changes, that means there will be no negative real zeros at all. And so you can cut down half of your list by not having to look at the positives or not having to look at the negatives at all.